Good morning, all of you. Welcome to the class. And today we resume after the discussions on searching, sorting, and basic array-based programming. And today, as last class also I told that now we will move to new data structures, and we are going to learn some fantastic new algorithms, some new data structure and their applications. To start with, let's recall one problem which we have sometimes studied probably, which is called as a TOI, Tower of Hanoi problem, TOH, Tower of Hanoi problem. I'm sure some of you might be aware of this. Some of you might not remember. So what TOH, Tower of Hanoi problem said was that you have a peg where you have lots of disks. Say peg means in between you have some kind of a nail or some kind of a khunta kind of a thing where you have various hold disks and they are placed one after the other with the rule that smaller disk can be only on the top of a bigger disk. So there were certain rules, and of course you needed this to be transferred from one peg to other peg via some in-between destination. So this could be an intermediate peg. This was your source peg. And here you have your destination peg. So the aim was to have these all n disks shifted to the destination peg. But there were certain rules. One disk at a time can move, and a smaller disk cannot be smaller or bigger disk cannot be placed on the top of a smaller disk. So this was something which you might have solved using recursion. So recursive solution, and it's a good recursive problem. For recursion also, you should try to understand how it works. So this you might have done. I'm not going in that detail, but what I'm interested to know is, let's say if I have this peg which has got, let's say 4 or 5 different disks. Say I have 4 disks. Let's number them, disk 1, 2, 3, 4. Say I am interested to take out disk 4 or disk 1. So my aim is to take out disk 1. So now you can easily see disk 1 cannot come out until unless you take out disk 4. So first of all, you have to take out 4. Then you have to also take out 3. Then you have to also remove disk 2. And only then now disk 2 can be taken. This is a special kind of a behavior. Let's say I want to take out disk 4 easily, no issues, because it was on the top. So if something is on the top, it could be easily removed, but if something is at the bottom, we have to go one by one. And this kind of a behavior is effectively called as a new data structure, which we call as a stack. So stack is a new data structure which follows the property of LIFO, last in, first out. In fact, whenever you are asked about a stack in any interviews, your answer has to be that stack is a data structure with LIFO property, and then you should be able to explain LIFO. What does that mean? It means that if you have, let's say, stack of integers, so stack could be of a different data. We are going to take off stack of int. It could be definitely stack of character, stack of a float, or stack of a struct, or anything like that. What does that mean? I have a stack. I will treat a stack kind of a this box where, let's say, you will say, I want to insert or add. They will be specifically named with certain operation. For the time being, let's say I want to add 20 to the stack. So 20 will be sent inside, or we call that as a push inside, as like this. Say after that, I want to put or add, let's say 30. So 30 will further go as this. Say then I want to push or send 15. So 15 will go like this. So this is what will be the standard way stack will grow. from bottom to top. Then if I want to take out, so the takeout will be only possible from the topmost position. Only one at a time and only topmost. So in this case, guaranteedly, the 15 will be the first to come out. And this is what precisely LIFO mean. 15 was the last to be inserted in last and first to come out. Last in, first out. Once you take out 15, your stack is left with 20 and 30. Now you take out, so 30 can come out, 30 removed, and only after that 20 can come out. So effectively, if you had, let's say 20, 30, 15, and now you have also added a 25. So I'll say guaranteedly 25 is the last in and it will be the first out. This is what we mean by LIFO. So stack will be very useful and probably this will be having lots of applications along with problems like Tower of Hanoi. We will see lots of real use applications. And if I say this, let me now recall whenever we have a data structure, any data structure, we consider that as an ADT. What is ADT? We have discussed sometimes back, for detailed read in the book also. But whenever we have any ADT or data structure, what we are interested in is two things. One, it's a storage, and other is its operations. So the question will be now how to store stack and what operations are allowed on the stack. But I go before those. Before that, let's recall, have we discussed some application of stack? Have we used some behavior or some question discussion where LIFO behavior was used? Last in, first out was being discussed, that the one thing which started at the last was first to finish or first to complete. If you remember, recursive execution, recursive calls, execution, and any recursion. For example, we talked of a factorial of a 5 initiated call to factorial of a 4, 4 initiated call to factorial of a 3, 3 initiated call to factorial of a 2, 2 initiated call of factorial of 1. Factorial of 1 was the last to be initiated, but first to complete. And then reverse. So this was a kind of a stack behavior. So effectively, your recursions implementation or recursions internal working that gets executed or implemented via stack. So your operating system, your computer internally uses a stack to implement recursion in this particular manner, because recursion guaranteedly requires the last in, that is the last executable function, to start and complete first, and reverse order will happen. Having understood that, I can easily see that stack has a variety of applications, and calling or making the recursive functions execution is one of the fantastic application of that. So now go for the stack storage. Let's go one by one. So for the storage, of course, it can be in variety of ways, but for the first time, we will be using it as array-based. Of course, it can be without array also, something like linked list, etc., which we will study later. So array-based means I will have something like int. If I'm wanting a stack of integers, I will declare int stack of some size. So that will mean, let's say if I have declared 100, so this will mean I get an array of 100 integers. But now I show it in this particular form. It's just a showing methodology, but because it will be more useful to understand how stack works. And I am expecting my stack to grow in this way. So int stack 100 will mean this. But Only this storage is not sufficient because I do not know up to what point it is full and where the next data can be put, or when I am trying to extract something, what is the topmost element. I wanted the topmost element to be extracted for the removal property. Similarly, next to the topmost element will be the data put. For example, I have 20, 15, 30. So 30 is stored at index 2. And if I want to store next value, it must be stored at this point. How do I know up to what it is full or which one is the next element to be extracted? So for that, we will have one variable top. So top will be another variable maintained where top is always supposed to be index or pointing to the topmost element of the stack. In case of array, it is index. In general, I could say it will be always pointing to. So this is what is top. So for the time being, I will use global variables for array and top. Later, of course, we will make them as parameters. So for the time being, I am using them as a global. What does that mean? That means I will have int stack and some size. Now we will have another change of programming that I will prefer to declare it as hash define max as 100, where hash means it's a kind of a preprocessor directive and hash define becomes a kind of a macro, and I'm declaring max as a constant which has a size 100. This is exactly creating this array. But there will be an advantage of declaring it as a constant or using hash define, which we will just see. And then I will also declare top. Data type of the stack could be int or char or float as per the need. Say we are working with stack of integers, so we will use this. Otherwise, it can be char, etc. But a top is an index, so top will be always integer. And the top must be initialized to something. What should be the initial value? You could think top to be 0. Yes, could be okay, that based on 0 I will work, but I will say 0 is incorrect. Why? It will violate the definition of what top is supposed to be. Although using top as 0 also, a lot of implementation can be done, but top is always the index to the topmost element. 0 is a valid index. At 0, some value exists. At present, your stack is empty. And if it is empty now, at that point, if a top points to 0, it means it is pointing to element 0. But element 0 doesn't exist. So 0 element is not having anything at present. So my top should not be at 0. Hence, I will say this should be initialized with -1. -1 because at present stack has nothing, and initially top will be pointing to topmost element. -1 means stack is empty, no element exists. As soon as some element will come, top should become 0, and so and so. So that becomes my storage. The rule is over this stack, you will not operate in between. You will not operate with any I. No, you will always operate it via top variable only. Say if top has reached to this position, top will be the only way which you will refer to any element in the stack. In between, you can't. So you will forget about other operations over array. You will use it via top only. Then operations. So primarily over stack, there are two standard operations. Again, they must be used with the standard name. One is called as a push, which is used to insert into the stack, and insertion obviously will happen on one end, that is towards the top end, and pop means to take out, to extract element. And take out an element obviously means topmost element. So these are the two standard operations which we define over stack. How to implement that? I must do that using modules, using functions. So for push and pop, I will make always functions, and it always means one element to be inserted or one element to be extracted via push and pop. Remember, whenever you define stack word, effectively you must be able to define stack saying that it's a LIFO property. It has operation push, it has operation pop, and it uses a topmost element or top index. So with these keywords only, the stack definition will be complete. How to have push as a function. So I mean, push function should be made, which is supposed to push some data. Push to be made as a function. So we must decide what should be the data type, what should be the parameters. Push will be called by someone, so it will be used to push or insert a data into the stack. For pushing that, remember, now I don't need a stack or top variables because they are global. For the time being, I am taking global. Later, I will be using them through parameters. Otherwise, of course, they should have been the parameters. But currently, we are taking them global. So what extra parameters I need? I need the value which I want to store inside. As my stack is of integers, so I will say int val, which is the value to be pushed. Normally, we expect if push happens, so nothing is to be returned back. Status is not returned back because array will be changing, stack will be changing. That will be automatic, and a global variable exists. So for the time being, this can be void until unless we have a special reason to return something. Push can be void also. How to push? Push will mean at any point, if my stack has some data, then next to that should be stored into the stack. Initially, top is -1. Top is somewhere here. And this is your index. So for the first time when I want to push, I have to use top and this stack array. In fact, every time the same thing, and every time the logic will be same. First time, say initially stack is empty and I want to push. Push is allowed, I can add the element. How to add? It cannot be at a top position. Topmost element is what a top points to. So whatever new element is being pushed to this, the top should point. That will mean, first of all, I will increment the top. And then I should store this element into the array. What value? This value which was supplied to you, you will be storing. From main, this could be supplied. In main, you could do the scanf, etc. Or from anywhere it could come. But purpose of the function is that from some external sources, this value will come. It will be supplied to this function and my stack will get received this value and store. But I will say, can I do this push every time? Yes, probably yes. But imagine if you have gone up to the last final position. You have top pointing to this place. Can you further put the data? Say it has got data 23. Now, once it has got already the data, obviously you can't put. So stack is full. So if a stack is full, I am not allowed to push. So ideally, my push function has to always check whether I am permitted to add more, whether it has the space to add element, and that I must check first. So if a stack is not full, only then I will do the corresponding value addition, whether you write top equal to top plus 1 or you write top plus plus, it is one and the same thing. And then I will write stop stack top equal to val. But what should be the condition? Obviously, this condition is dependent on a top versus size. Size, we have already said, is max now. So now the size versus the top I have to decide. Condition could be something like this. I could think, yes, it will be something like top less than max, less than equal to, or max minus 1, around that. How to verify? Just imagine, let's say max is 100. I have already said max has 100. So if a top is, let's say, 100, top 100 is incorrect. 100 will mean I'm pointing to outside 0 to 99. It is obviously not okay. Just imagine top has reached to 99. So if a top is 99, it actually means the 99th index is full. This has got element. If it has got an element, I can't further add element to this stack. It means the stack is already full. So even if I say if a top is less than max, max is 100. If a top is 99, it will be incorrect. If top is 98, yes, top 98 means I'm allowed to store up to 99. At present, top is here. This has got value, let's say 27, but this place is free. So I can definitely store on the next place. So if a top is up to 98, I am permitted, otherwise not. That means I should write, if a top is less than max minus 1, it is permitted and stack is not full, otherwise stack has become full. If a stack is full, I must give the message, of course. Of course, if needed, you can return this as a symbol special, but normally for the time being, I will say, I must give a message, stack full, push not allowed. This message should go to the user, and that's what I will do. So this becomes my push function. So I must check whether stack is full or not. Going further, let's see the next second operation. Parallel will be the similar other operation which we want to pop. So how to pop? Again, I want to make a function. I must decide its return type. I must decide its parameters. For working the pop, stack and top will be definitely needed, but they are global, so need not pass as a parameter for the time being. What else? Nothing else is to be supplied to this function to pop, because from outside I don't need anything to tell how to work on pop. But yes, what pop will return is one element that is of int type for the time being, because my stack is of int type. So my return type will be this, and I have nothing as a parameter. Of course, now I must check this also similarly. If a stack has some data, only then it can pop. If a stack is not empty, then only I can pop. If a stack is empty, obviously it is not going to permit this pop operation. So I must check whether stack is empty or not. How to check that? Of course, a top variable will help me. Versus what? Not versus max. Because max tells the maximum limit. Initially, stock was empty. Max is going to tell the stack as full. When was it empty? When top was effectively minus 1. If top was a 0, it doesn't mean stack is empty. It means it has some element, pop can be allowed. So that means I should check here top equal to minus 1. In better words, I will say I must check it as top less than 0. If top less than 0, it means pop is not permitted and I should have some special, it means empty status. Else, I will be able to work further. Top less than 0. That will mean stack is empty, and empty I can give a printf message here. That will be fine, but that will be incomplete because return type must be executed and returned for every situation. So I must make sure to do that part also. I'll just see that. First, let's come to the else part. Else part means now I want the topmost element to be returned. And not only that, top should be updated. Let's say if I have this stack, say I have here 26, top is this position. So what, let's say top is, let's say currently 7. So next time what should happen? Before 26 there was, let's say 28, here I have, let's say 15 and like that. So after pop, what I should have? Whatever I had, 50 and 28. And that should become my top. So earlier top was 7, now top will be 6. And 26 should be returned back and top should be updated. So I think that I should do top equal to top minus 1. And then I should return the value which I have got. So return stack top. Yes, prima facie, it looks to be okay, but I will say what this will return. If top was 7, top got decremented, top became 6. Stack top actually will return 28, not 26. I wanted 26 to be returned. So you could think, do something like this. But again, I say, if you do like this and bring this statement downwards, still it will be incorrect, because as soon as you write return, value will be returned 26, okay, but this will not execute. Because after return statement, next will not get executed. So this is not going to be okay. Hence, I have to improve my coding to make sure that I handle everything correctly. So how to do that? I will say if top less than 0, of course, I will have something here. Else. What? Else I will say, I will take a temporary variable val, store there this 26, whichever was. So currently top is at 7. This val gets 26 stored. Then I will decrement top because return statement should not get executed. And now I will say return val. So before return val, top has been updated, value has been stored. So I can have a local variable int val, and through that I can return. Of course, this can also be done by a single statement. Those who can understand, they should think of doing this, but those who are not able to understand this need not bother. Read a book and you will be able to understand how it works. So top minus minus here has all that working in a simple manner. Remember, this statement top equal to top minus 1 is equivalent to saying top minus minus also is also equivalent to say minus minus top. Here it is okay, but if I wanted both operations to be done, I must know how it works. If you do not know, you can safely use this code. This is perfectly fine. No efficiency loss. Just you have to type 2 extra statements. Perfect, no issues. If top was less than 0, the stack is empty. So in that case, I must be able to return something. Return a special status, error status. So for example, I could say return minus 100, where I am assuming that minus 100 is a special value which tells that pop was unsuccessful. That also means minus 100 was never used, never pushed into the stack. Because if minus 100 was being pushed and through that return val minus 100 is returned back, I have no decision to make whether minus 100 came because of return val or it was because of a failure, because of unsuccessful or empty stack. So I will reserve one value, something like minus 100, which will be used to return the status. So by this, you should be able to do programming easily. Now I am saying, based on this, you should be able to implement push and pop. There are two more operations sometimes, if we want to use, can be that I can implement sometimes is a stack full. It's a Boolean function, is a stack full, which should tell whether it is true or false. So it can be int or Boolean type. So it should return true or false. True word effectively means we normally return it as 1, and false means return as 0 because we take int. Bool data type is also supported in some compilers with some standards. So if you are able to use bool, good. Otherwise, you can simply use int and return 1 or 0. So of course, this can be checked with top versus max, and you should be able to tell whether stack is full or not. Similarly, we also usually provide another operation which we call as is stack empty to tell whether stack is empty or not. Again, no parameters needed, bool type, return type, and this also should return 1 if stack is empty, and it should return 0 if stack is not empty. So is stack empty? True means yes, it is empty. How to do that? You have to effectively check top with less than 0 or top not less than 0, something like that. Top is less than 0 means obviously stack is empty. You could say top equal to -1 also. That is also one and the same thing, but this becomes ensuring that even if top is any negative value, that will be considered as an empty stack. So these two are also two standard operations which are supported. So this is effectively operation 3 and this is operation 4. And first operation was push. So I say push is operation 1. Pop is operation 2. And we also provide is stack full, is stack empty as two more operations. This is operation 3 and 4. But of course, push and pop will be used, and internally they are automatically using stack full and empty. So stack full is already being used into push, stack empty is already being used into pop. So if you write these as separate functions, those you can write in that also, or the same way you have written, your choice. Having said that, now let's wind up. So I'll say, now let's understand the homework. So for the homework, I would like you to use main, and I have to implement stack and its operations. But I should be able to verify all operations through all sequence. So what I want a main to have some special features. I will explain what I want you to try. But before I go, I told you that we will be using max for certain reasons. Why did we use max? So now you can easily see the purpose of max is that if you write like constant declared, advantage being at any point you can change this, and throughout the code nowhere else a change will be needed, because everywhere else you have used this word max to refer to the total size. Here also you have used max. In your full status or in your push, you have written if top less than max -1, something like this. You have used word max. Let's say this 100 you change to 200. Immediately your code is ready to work with stack of a 200 size. Automatically this will become 200. Automatically this will become 199 and everything will be fine. If you don't use max, you might have written here 100, you might have written here 99, you might forget to change at this place to become this as 199, etc., etc. Not only that, say I want you to try, check whether full stack message is correctly coming or not. So you will not be interested to push 100 elements. Maybe I will say, just change it to a small stack and take the size as 5. Then after 5 push, you should be able to see that the stack has become full. That will require your stack size to be reduced to 5 from 100. Then you should be able to easily do those changes without requiring anywhere else any change to be done. So advantage of defining max word is like this. So now coming to how to make your main. So what I want you is, in main, you should give choices. You should ask user, press 1, 2, 4 for operations. I want you that you should implement give 1 for push, give 2 for pop, press 3 to display the all stack, so that I can verify whether my stack is growing or shrinking correctly or not. And I give 4 for exit. And I keep on repeating these choices. So I can repeatedly ask the user that press these, and till exit is not selected, keep on repeating. So until you select exit, you keep on repeating. So for example, I might say, okay, push. So it asks me scanf, what value you want to push? Say I push 5. So it should mean my stack becomes 5. I again say push 8. It should store 8. I again say push 11. It should store 11. Then I say pop. So pop should display 11. Then I say again push. So that will mean 11 has gone, and now I have pushed, let's say 7. So 7 comes here. I again say push 9 or push 2. So 2 comes here. So in between, I can do many operations. Maybe now I say display the stack contents. So my display should tell me that currently stack has 5, 8, 7, and 2. Of course, this display will be possible by using one loop, and you can do that. But otherwise, in stack, normally we are not permitted to refer to individual elements of the stack without referring to top. But just to verify my results, I'm giving this operation so that I can check that my result is correct. So similarly, you should be able to also explore the full condition or the empty condition. For example, I say I will take stack as 5, and after that I will say push 20. 20 should be allowed. And now if I say push 25, it should tell it's already full because size was 5. And we already have 5, 8, 7, 2, and 20. This push was there. So that I will be able to verify. Maybe again I say push 30. Again, I should get full condition. Similarly, I could go for pop. Now pop should be in 20 pop. Again, I could go for pop. Again, it should be 22. Again, maybe pop 7. Again, pop 8. Again, pop 5. Again, pop. I should get message empty. How to get empty status? My call to pop will check whether -100 returned or not. If -100 returned, my message should be stack was empty. Otherwise, the stack value which was popped out, that will be displayed. Maybe again I try pop, again says empty. Now I say display stack, that should show no stack contents. Now I say push, I should be able to push. Say push 30, so I should get 30, and accordingly go on. Whenever I select exit, only then my program stops. So for option when I give, then program stops. This is what I want you to try and implement the stack corresponding. Having said that, now going to the final remarks, then I'm giving you one extra homework which you should try. So it's an optional practice problem. stack you must implement along with all operations, and optional practice problem I'm giving you to use stack and find out whether a given string is palindrome or not. So I'll say using stack, find whether a given string is palindrome or not. I hope now you remember what is a palindrome, the one which reads the same from both sides, like R, A, D, A, R. Read like this, same. Or maybe A, B, B, A. Read like this. So odd length, even length, both can be there, etc. O, 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 P, P, O. Again, a palindrome. So I want now use stack. Think how to use stack. Some of you could think that I will take extra array and through that you will do. Yes, that can be okay, but I don't want you to try with that. Then the basic purpose of using stack will be lost. If you push all elements and then reversely stored into extra array and then compare two arrays, that is not that a good use of a stack. So I want to think some other way that you use a stack and you had your original palindrome, then original string, can you try to implement this? Just to think over that. Those who want a hint, they can listen to my next line. Those who wanted to try, they should not go to the video next continuation and they can pause here and try. Those who want a hint, I will say, yes, using stack, it could be possible by going up to the half of the stack, the string to be traversed and pushed, and then that can be verified for the remaining half. That much hint should be sufficient. With this, I will stop. Right? So now with this, I will stop, and next class we will resume with some applications of the stack. Some more applications we will discuss, and that will be the next lecture. So bye-bye, and all the best to all of you. Try and implement a stack and its operations, and optional practice of finding using stack whether a string is a palindrome or not. Bye-bye. All